Good day, all of you. This is Mr. Ahmed, your math and physics teacher. Today we're going to talk about circle theorems regarding the GCSE mathematics. IGCSE, this works for all of them actually. IGCSE, GCSE, Edexcel and Cambridge. These are the theorems that we're going to cover along with their proofs. Semicircle, center, cyclic quadrilateral, same segment, alternate segment, and tangents. Before we get into them, let's learn about the parts of the circle. This is a circle. The outer space around the circle is called its circumference. Diameter. The diameter is connecting 2 points at the surface going through the center. Radius, connecting point in the circumference with the center. Any point in the circumference along with the center. The diameter is double the radius, and the radius is half of the diameter. A chord connecting two points in the circumference. So that means the diameter is a type of chord, but it's a special type of chord where it passes through the center. It divides the circle into two equal semicircles, but this divide them into two segments. The upper one is called the major segment, and the smaller one called the minor segment. It's called the minor segment, and this is called the minor arc, and the minor arc is this part from this point to this point. This all is called the minor arc, and this is called the major arc. Minor sector, major sector. Any line that passes next to the circle and it touches the circle at one point of the circumference is called the tangent. It's called the tangent. So we'll start with the first theorem. It's angle in a semicircle. This is a semicircle. Angle at the circumference in a semicircle is always 90 degrees. Let's prove that. If we draw a radius from the center, this becomes two isosceles triangles, because this is a radius and this is a radius. This is also a radius. These are equal to each other because they are all radiuses, right? This and this are part of this triangle, which makes it a isosceles triangle, and this also becomes an isosceles triangle because it has two equal sides. Now, when a triangle has two equal sides, of course, the angles opposite to the sides that are equal as well. So each one of them is equal to 180 minus x divided by 2, because the sum of the angles in a triangle is equal to 180. So each one of them is 90 minus 2, 90 minus half x. And of course, this angle along with the x, both of them, they make an angle of 180 degrees, a straight angle. That's why it's equal to 180 minus x, which make the other two angles 180 minus x minus 180 minus x over 2, right? This is 180 minus x. 180 minus 180 minus x is over 2, which means it's equal to half x. Then the sum of the two angles, this angle and this angle, is equal to 90. So this proves that angle in a semicircle is 90 degrees, or simply apply angle at the center. We'll talk about it here in this theorem. Angle at the center, always angle at the center is double the angle at the circumference. This angle is double the angle at the circumference, because if they are coming from the same arc, so they double this the angle at the center is double the angle at the circumference. Let's prove that. First we draw radius. Now we have two isosceles triangles as well. This angle is equal to 180 minus x over 2, and this angle is equal to 180 minus y over 2, isn't it? Because these two isosceles triangles, the angles opposite to the equal sides are equal as well. That means 180 minus half x minus half y, and this is all 360, right? When we subtract from it minus y minus x is equal to this angle is equal to 360 minus y minus x. Of course, this is double this, right? Because 360 divided by 2 is equal to 180. Y divided by 2 is equal to half y, by x divided by 2 half x. That means the angle at the center is double the angle at the circumference. Now, opposite angles in a cyclic quadrilateral add up to 180. X and y add up to 180. This angle and the angle opposite to it also add up to 180. But the condition of a cyclic quadrilateral that all the corners touch the circumference. If they're all touching the circumference, this is what we call a cyclic quadrilateral. Apart from that, it's not a cyclic quadrilateral. In a cyclic quadrilateral, the opposite angles always add up to 180. Let us prove that. First, we draw radii from this part to this part. Apply the angle at the center is double the angle at the circumference. This angle is double this angle, right? 2x and this x. This angle is double this angle. That means 2x plus 2y is equal to 360 because they are angle around the point. If 2x plus 2y is equal to 360, that means we could extract 2 as the greatest common factor. 2 times x plus y is equal to 360. If we divide both equations by 2, both sides by 2, we get x plus y is equal to 180, which makes the x and y when they add up to 180. Opposite angles in a cyclic quadrilateral add up to 180. Moving on, angles in the same segment. They are in the same segment. They're coming from the same arc and they're lying in the same segment. Angles created by triangles are equal if they are in the same segment. Let's prove it. First, we draw radii from this part to this part, and then we apply the angle at the center. The angle at the center is always double the angle at the circumference. So this means that this angle is double this angle. And the same angle is double to the other angle, which is y. That gives us 2x is equal to 2y, where x is equal to y. Angles coming from the same arc in the same segment, they are equal to each other. Alternate segment angles between a tangent and a chord. This one is equal to the angle at the circumference in the alternate segment. This angle is equal to this angle, and this angle is equal to this angle. Start with two of the circle theorems. Angle in the semicircle is 90 degrees, and angle in a tangent is between tangent and its radius is always 90 degrees. Now combine them together. This angle is equal to this angle. 90 is equal to 90, right? Label an angle x. If this is 90, that means this whole angle is equal to 90. If this is x, that means this is 90 minus x. X is equal to x. simply apply the same segment. This angle is equal to this angle and is equal to this angle. Now the length of tangents to a circle which meet at a point are equal in length. These are tangents, both are tangents that are touching the circle at one point. If they meet at a certain point, which is C here, that means they are equal in length. Let's prove that. We draw two radius, apply the angle between the tangent and the radius. This angle is 90, A is 90, B is also 90. They have the same radius. This side, since this is a right angle and this part is x, so we could apply Pythagoras theorem and we get this side as the square root of x squared minus r squared, and this also will become the square root of x squared minus r squared, which means they are equal in side. Perpendicular tangents, the angle between a tangent and a radius is 90 degrees. Now let's move on to past paper questions and try to answer them. First question, you must give reasons for any answers provided. All diagrams are not drawn to scale. A, B, C are points on the circumference of a circle. Center OAC is the diameter of a circle. Write down the size of angle ABC. This angle ABC. Of course, from the first one, the angles in a semicircle is always 90 degrees, which means ABC is equal to 90. Now, given that AB is 6 centimeter, BC is 8 centimeter, work out the diameter of the circle. This side is equal to 6 centimeter, and this side is equal to 8 centimeter, right? So we want to get this one. Since it's a right angle triangle, this is represent the hypotenuse. We could apply Pythagoras theorem to find the diameter of the circle, which is equal to x is equal to the square root of 6 squared plus 8 squared, which is equal to the square root of 100, which makes the diameter of the circle 10 centimeter. Now you want the area of the triangle. The area of the triangle is half base times height, which is equal to half times 6 times 8. Half times 6 times 8 is equal to 24 centimeter. Centimeter squared, because we're talking about areas. Now the area and the circumference of the circle, leaving your answer in the terms of pi. Now if you want the area of the circle, area is equal to pi times r squared. But how can I get r? I have the diameter that is equal to 10. So r is equal to 10 divided by 5. 10 divided by 5 is equal to 2. Since I have 2, then I could get 10 divided by 2, is equal to 5 centimeter. So 5 times pi times 5 squared, which is equal to 25 by centimeter squared. That's the area. And the circumference is 2 pi times r, which is equal to 2 pi times 5. That's equal to 10 by centimeter. Let's check our answers. $90 is the right angle. This ABC is a right angle. The diameter of the circle, x squared is equal to 6 squared plus 8 squared, it's equal to 100. That means x is equal to 10 centimeter. The diameter is 10 centimeter. Half times base times height. Half times 6 times 8 is equal to 24 centimeter squared, and so on. Now, question 2. P, Q, R, and S are points on the circumference. P, Q, R, and S. Angle PRS is equal to 65. Angle QSR is equal to 44. Find the size of angle PQS. This is, if this is the same arc, these are angles coming from the same arc at the circumference. This means it's equal to this, so it's equal to 65 degrees. PQS is equal to 65 degrees. QPR, we're looking for QPR, this one. QPR is equal to, also they're coming from the same arc. This one is equal to this one, so QPR is equal to 44 degrees. Now PQ and R are points on the circumference of a circle, center O. PR is the diameter of the circle and ST is the tangent. PR is the diameter and this is the tangent. Angle QRS is equal to 58. It's given. Work out the size of angle QRP. We know that angle at the tangent is 90 degrees. This is all 90 degrees. That means if we subtract this from 90, we get the size of QRB. QRB is equal to 90 minus 58, which is equal to 32 degrees. Work out the size of angle QPR. If this is 32 and this angle in a semicircle, which is equal to 90, then we've got 90 plus 32, that's equal to 122. And we want to find this angle, which is x, then x is equal to 180, because the sum of the angles in a triangle is equal to 180. 180 minus 122, which is equal to 58 degrees. 58 degrees. That means angle QPR is equal to 58 degrees. Thank you all for watching. This will be our last question from past papers. Please, if you do have any questions, please write them in the comments below and I will be happy to answer them. Thank you all for watching. Please, if you are new to my channel, subscribe and share it with your friends.